AT2062, Chapter 3. Fuel pump. Fuel pump. There are two types of fuel pump, the in-tank and in-line type. In-tank type. This type of fuel pump is mounted inside the fuel tank and is less noisy than in-line type. This type of pump has the following parts. Relief valve. The relief valve opens when the discharge side pressure reaches approximately 350 to 590 kilopascals. The relief valve returns the highly pressurized fuel directly to the fuel tank to prevent the fuel pressure from rising too high. Check valve. Check valve closes when the fuel pump stops. This is done to maintain the residual pressure in the fuel line when the engine is stopped for easy starting. Turbine pump. The turbine pump consists of one or two impellers driven by the motor, the casing and pump cover, which compose the pump unit. Impeller. The impeller rotates along with the motor when it turns. The blades on the outer circumference of the impellers pull the fuel from the inlet port, going to the outlet port. Fuel discharged from the outlet port passes around the motor. Then, the fuel is discharged from the pump through the check valve. In-line type. This type of fuel pump is mounted outside the fuel tank. This pump consists of motor and pump unit, check valve, relief valve, filter and silencer. The pump consists of rotor that rotates when the motor turns to pump the fuel. The fuel flows through the motor unit, opens the check valve, and passes through silencer before going out of the fuel pump. The relief valve and check valve have the same functions as the in-tank type fuel pump. Fuel pump control. The fuel pump only operates when the engine is running. Even when the ignition switch is turned on, if the engine is not running, the fuel pump will not operate. Ignition switch on. When the ignition switch is at IG position, the EFI relay turns on. Ignition switch start. When the engine cranks, the STA signal or starter signal, coming from the ST terminal of ignition switch, is sent to the engine ECU. When the engine ECU receives the STA signal, it turns on the transistor. Then, the circuit opening relay turns on, and the current flows to the fuel pump. Engine cranking or running. While the engine is running, the engine ECU receives the crankshaft position signal coming from the crankshaft position sensor. The crankshaft position signal holds the transistor on to keep the circuit opening relay on, thus keeping the circuit opening relay on, and the fuel pump operates continuously. This turns off the circuit opening relay and causes the fuel pump to stop. Without any signal, the engine ECU turns off the transistor. if engine is stopped. If the ignition switch is on, and the engine stopped, any signal will not be input to the engine ECU. Without any signal, the engine ECU turns off the transistor. This turns off the circuit opening relay, and causes the fuel pump to stop. This brings us to the end of this topic.